Genesis of periodic classification. The classification of elements, their division in groups, and also their periodic properties is the result of gradual developments. Let us have a look at those developments. Johann Wolfgang Dobereiner was a German chemist. His effort is considered as one of the earliest attempts to classify the elements into groups. He found that when elements are arranged into groups of 3 in the order of their increasing atomic mass, the atomic mass of the element, which comes in the middle, is the arithmetic mean of rest of the two. On this basis, he arranged 3 elements in one group, which is known as triad. This arrangement of elements is known as Dobereiner's triads. Dobereiner could find only 3 such triads, group of 3 elements, and he could not even put all the elements known at that time in his triads. After the advancement of techniques of measuring atomic mass more correctly, Dobereiner's law became obsolete. Newlands found that every 8th element has similar physical and chemical properties when they are arranged in increasing order of their relative masses. This law is known as Newlands' law of octaves. For example, sodium is the 8th element from lithium and both have similar properties. But the limitations were that Newlands' octaves could be valid up to calcium only, as beyond calcium, elements do not obey the rules of octaves, and also Newlands' octaves was valid for lighter elements only. The periodic law, as we know it today, owes its development to the Russian chemist Dmitry Mendeleev, 1834 to 1907, and the German chemist Lothar Meyer, 1830 to 1895. Dmitry Ivanovich Mendeleev, a Russian scientist, arranged the elements in increasing order of their relative atomic masses. He was honored with Nobel Prize in 1906 for his periodic table. Mendeleev's periodic law states that the properties of elements are the periodic functions of their relative atomic masses. Mendeleev arranged all 63 elements which were discovered till his time in the order of their increasing relative atomic masses in a tabular form. It is known as Mendeleev's periodic table. He divided the table in 8 columns and 7 rows. The columns are known as groups and rows are known as periods. Elements are arranged in the periodic table in the increasing order of their relative atomic masses. Mendeleev divided his periodic table in 8 groups and 7 periods. Groups from 1 to 7 are meant for normal elements and group 8 is for transition elements. Groups from 1 to 7 have been divided in 2 subgroups, while group 8 is meant for 3 elements. Periods from 4th to 7th have been divided in 2 series, first series and second series. Elements having similar properties have been kept in the same group. For example, lithium, potassium, rubidium, etc. are in the first group. Position of hydrogen. Hydrogen has been placed in first group with alkali metals, since hydrogen makes compound in the same way as alkali metals do. On the other hand, hydrogen exists as diatomic molecule, similar to halogen, and hydrogen makes covalent compounds also as halogens do. Thus, on the basis of properties of hydrogen similar to halogen, hydrogen may be placed with halogens, but Mendeleev did not explain about this anomaly. Wrong order of elements. Mendeleev placed many elements in wrong order of their increasing atomic masses in order to place elements having similar properties in similar group. Example, the atomic mass of nickel is less than that of cobalt. In spite of that, cobalt is placed before nickel. The atomic mass of chromium is 50.20 and the atomic mass of vanadium is 50.94. In spite of this, chromium is placed after vanadium. In spite of above limitations and anomalies, the Mendeleev's periodic table was one of the wonderful discoveries.